Hello, I'm Garrett Wynn, and this is my final project for Honors Chem, which I explain equilibrium in chemistry, physics, biology, and a real-world experience. Firstly, what is equilibrium? Equilibrium is when opposing forces or influences are balanced. How does it apply to chemistry? The term in chemistry is referred to as chemical equilibrium. It is the condition in which the course of a reversible chemical reaction in which no net change in the amounts of reactants and products occurs. A reversible chemical reaction is when the products, as soon as they are completely formed, react to produce the original reactants. A dynamic equilibrium is a state in which the rate of the forward reaction is equal to the rate of the reversible chemical reaction. A good example would be soda. The CO2 in the sealed bottle is present in both the liquid aqueous phase and the gas phase, which is the carbonated bubbles. This is also called ionic equilibrium. And on the bottom, you can see the dynamic equilibrium and how the diffusion balances out over time. And on the right, you can see that the reverse and forward reaction over time turn to equilibrium and they balance out. How does equilibrium apply to physics? Equilibrium in physics is the condition of a system which neither its state of motion nor its internal energy state tends to change with time. Equilibrium rises if the vector sum of all the forces of a single particle is zero. And equilibrium is unstable if the least departure forces that tend to increase the displacement. If the size and direction are balanced on an object, then there is zero net force acting on the object and the object is in complete equilibrium. In mechanics, mechanical equilibrium, if the net force of the particle is zero. Also, a physical system made up of many parts is in the mechanical equilibrium if the parts are zero. How does equilibrium apply to biology? In biology, the term equilibrium has a different meaning. Equilibrium is the process by which the animal and vegetable organisms preserve a physiological balance. A system in equilibrium requires no energy to maintain its condition. An example is a water barrel with membrane. If you add dye to one side that is able to fuse across the membrane, over a time, the concentration, the molecules in the dye will become the same on both sides. In biology, equilibrium has very different concepts, but it entails systems working together to create balance. How does equilibrium apply to the real world? A seesaw is a great example. When the masses of both sides of the seesaw are the same, the seesaw reaches equilibrium and the balance, it's like balancing on a measuring scale. But when one side is greater than the other, the system is not in equilibrium and the seesaw turns to the bigger mass. In a properly made seesaw, the center of gravity is achieved when the plank is exactly over the middle, so it doesn't tip one way or another. The whole weight of the plank is given to the center of gravity in which it rests on. When the center of gravity is balanced, then the system is in equilibrium. Finally, tug of war is a real world example of equilibrium. The tension on the rope is pulled by each ends, which makes the middle part of the center in which the pull is taking place. This is actually an example of dynamic equilibrium, which is when the clockwise and counterclockwise systems are equal. Thank you.